I'm thrilled to welcome Dr. L. Venkata Subramaniam, head of IBM Quantum India, to my very first podcast. With a PhD from IIT Delhi, 34 patents, and over 150 research papers, he's a trailblazer in quantum computing. As the author of the best selling book Quantum Nation, praised for his vision and impact, Dr. Subramaniam is driving India's rise in the global quantum landscape. Get ready for an inspiring conversation with this visionary leader. Thank you so for being here today. And congratulations on your book. I've seen that they've received incredible reviews. And I was also reading through it and it was very insightful for me. And I love the chapters, especially that you included quantum hardware and the semiconductor part as well. Uh, so I would like to start with, because I have an audience which doesn't know much about quantum computing as well. They're trying to start, some people from school, high school students. So I'd like you to introduce them to quantum computing, if you could, in like a few sentences.
Yeah, sure. And so, first of all, thank you, Kiran, for having me here. I'm really happy to be here. Such a young person asking so many incisive questions and taking it to a young audience. So, thank you. It's great work you're doing.
Thank you so much.
And I see you are inspiring a lot of other youngsters also. So, thank you for your work also, first of all.
Thank you, sir.
Um, so you asked about, what is quantum? So for the first time in history, okay, computing is branching. So there are now two types of computers. One is your mobile phone, laptop, supercomputer, all of this, which uses bits to as the fundamental unit for computation, zeros and ones. Now, on the other side, now there is a new kind of computer, which is the quantum computer, which not only has the bits, but it also, the qubit or the quantum bit can basically take on all values between 0 and 1 simultaneously. Okay. And that gives it some exponential compute power on certain types of problems. Okay. So, and what are those problems? Things like molecular simulation. So if you're trying to simulate nature, for example, how molecules behave, how proteins, your body has several proteins, how do they fold, what kind of three-dimensional structures do they take up, how do they bind with other kinds of proteins. That's one class, nature simulation. The second class is all this mathematical, where there is complex mathematics involved. Things like, there is this problem called the prime factorization problem. What is prime factorization? What are the prime factors of 15? 3 into 5. But what is the prime factor of a very large number? It's very hard for a classical computer to, compute that. In fact, it takes billions of years for large integers. And that's the basis for our cryptography today. Okay. So all of our cryptography is based on this complex maths, which says that you cannot do prime factorization quickly enough on a classical computer. But a quantum computer can do that very fast. Okay. So here are some class of problems like molecular simulation, which is there in drug discovery, which is there in new materials, which is there in, finding new batteries, finding new kinds of fertilizers, everything where there is molecular interaction happening and you want to figure out how does that molecular interaction take place. All of that can be done on quantum computers much faster. Similarly, the data which has complex structure like this factorization problem, right? So now there is, as I said, computing has branched, two kinds of computers, and each one special in its own ways, and the quantum computer is very good at doing certain problems like molecular simulation.
Thank you. Thank you for that introduction. So my next question would be, what do you think about the quantum hype that's been made recently in the last few years?
Yeah. See, I feel hype is important because what does it do? It allows youngsters to know about a field. It's advertising basically, Hype is advertising, It's about telling young people like you, your classmates, everyone around you that look, there is now a new kind of computer out there called the quantum computer, which can solve some very tough problems. And are you now up for it? Because now this branch is starting, this area has just begun. And if you get in, you are like a new explorer, exploring new things, new concepts, and you could make a big change, big difference, right? And I think that is a very um, exciting thing for young people, because I see that same thing happening with AI. Young people are seeing, oh, here is a tool for us which can solve certain kinds of problems which were not able to be solved. Okay, now you have every computer, everybody is using things like chat GPT, and you are now able to answer questions based on a collection of documents which you could not earlier. Very nicely, the system is able to answer questions. And now people are thinking, oh, what kind of questions can I answer? Can it answer questions in biology? Can it answer questions in politics, law, all of these things? So ChatGPT has opened that world for everyone, right? So similarly, in quantum now, we are trying to figure out, here is a special kind of computer which can solve some problems which you cannot ever solve with the classical computer. And so now, with using this computer, let your imagination run. And here is a tool for you. Take that tool, and what are the things that you can do with it, right? And that hype helps these youngsters, broaden their imagination and get started. After that, maybe they get interested, they don't get interested, they go into other areas, but at least you become aware and you're able to contribute to this new emerging area.
Yes, I completely agree with you on that point. My next question would be, I'm seeing that we are facing a lot of challenges in scaling quantum computers. Could you explain something about that?
Yeah, sure, sure. So, see, there are two or three important parameters about a quantum computer. One is the number of qubits. Okay. So, the qubits, as I said, are the fundamental unit of computation on the quantum computer. And right now, at the end of 2024, IBM released this 156 qubit Heron processor. Okay. You might also have heard about the Google processor, which is a 105 qubit Willow processor. So now these quantum processors have crossed 100 qubits. Okay. So that's number one part. Now, you can, of course, keep increasing the number of qubits, but if they are very noisy, then that doesn't help either. So the number of qubits that you have created need to be noise, they have to have less noise. Okay, so that's the other requirement. So you can keep adding more qubits, no problem. But if they are very noisy, then you cannot compute with them. So this 156 qubit processor from IBM is currently one of the most advanced, where it enables you to do faster computation. It gives you low error rates for the gates or the basic units that you use to build your circuits, your computational circuits to solve problems. So you use the qubits and you connect the qubits using what are called the gates. Okay. So now this new Heron processor allows you to, of course, it has 156 qubits, but it also allows you to add a number of gates, so around 5,000 gates for error-free or very low error computation. Okay. So which means that now you are able to solve some somewhat bigger problems using this quantum computer. Now, of course, from this 100, and when we started out in 2016, there was 5 qubits. 2024, there were 156. 2033, we are likely to have 1 lakh. Okay, qubits. So you see a Moore's law equivalent here, in terms of the scaling. Yes, there are challenges, as you pointed out, in terms of adding more and more qubits, while at the same time keeping the noise low, while at the same time enabling more gates to be used in your computations. and being able to run that in a reasonable amount of time, right? So these are your sort of the metrics which you are going to use for building your computer, right? So, and we are seeing that that scaling is happening, as I said, from 5 to 156 to 1 lakh. So all of that is happening. And now what is also happening is people are now looking at, okay, there is the 156 qubit. What can I do with it? Which problem can I solve with it? So the algorithms people now have a tool where they have a reasonably fast, reasonable number of qubits with a reasonable number of gates to work with, to say that, okay, I will solve this problem in molecular simulation, or this problem in complex data structures, or this problem in optimization. So both the sides, the hardware keeps improving. We are seeing it improving. Now the algorithms and software people are also coming in and saying that I'm going to make this a usable computer. I'm going to provide tools like Qiskit, the programming language, which enables somebody to come and start using this computer. You don't have to be a physics PhD to use it anymore. You can, whatever knowledge you have, whether it's biology, chemistry, computer science, here is a tool which you can now start using without knowing, being a PhD in physics, to come and try and solve real life problems. Okay. So I think now that acceleration phase is hitting in, where people now have this tool, people have that sufficient knowledge, the level of abstraction on the software layer has happened to some extent, which enables non-experts to come and start using it. So all the things are falling in place. And I believe this is the decade when all the major initial breakthroughs are going to start happening.
Yes, sir. You're true. That's true. So my next question would be connecting with your book as well, Quantum Nation. What do you think about India's position in the global quantum race right now?
Yeah. That's a very important question. And I must say that youngsters like okay, have ensured that we, even though colleges are not teaching quantum, okay, very few colleges are, maybe 10, 15 at this point of time are only teaching, only those colleges are or universities are teaching quantum. But from somewhere, we have a huge number of people who are quantum aware and quantum trained students. Okay. Young people, 18-year-old, 19-year-old, 20-year-old, 21-year-old. These people have self-learned using the tools and the learning materials which is there online. And they are using the free quantum computers from IBM. Okay. The quantum computers have been available for the past almost 8, 9 years now, right? So they have been using that. Nobody has told them, go and use. They've just been using it. And one way or the other, they've put India at the top, right? In terms of people who know quantum, who know how to program these computers. They are all good at Qiskit and programming. And I think our background in having mathematics and programming go together, you can find programmers everywhere, you can find mathematicians, but it's only in India you find people who are good at both and who are able to build solutions using maths plus programming, okay, to solve problems. Okay. So that, I'm telling you, I see huge amount of talent in India that we don't see anywhere else. Okay. And this is our time to focus, leverage, and utilize that talent to build things right now.
Yes, sir. And so which big tech company do you think would reach significant quantum advantage first, in your opinion?
Yeah, okay. So I work for IBM. So
Yeah,
I'm going to say that IBM systems
yeah,
will be the first to, on which quantum advantage will be achieved. Okay. But remember, I'm saying IBM systems will enable, but who's going to bring out that quantum advantage? I mean, I just told you, talent is sitting here in India. So somebody in India has to bring that quantum advantage. The system is there. And as I said, India is one of the highest users of these systems, right? And so we have all the young people doing mathematics plus programming, Qiskit, very good at it. Now we need to enable these young people to come up with those solutions, okay, which are going to, because anything, you look at NVIDIA, okay. Now NVIDIA is one of the most valuable companies in the world. But what was it before OpenAI? It was just a normal tech company, okay. Nothing very special about it. The day OpenAI came out with ChatGPT, NVIDIA stock rose 900%. Okay. So everyone needs one big application that showcases that technology's worth. Okay. So for quantum, we need the algorithms people, we need the applications people, we need the young people to start thinking that, okay, now I have this 156 qubit quantum computer, which I can access for free on the cloud. Uh, Now, what is that application which I can go and solve using this? Okay. So the talent now has to be focused on using the hardware which is there to solve some real life problem, because that's when it becomes useful. Otherwise, it is sitting in the lab. Nobody cares. Nobody cares about it, right? The common man started caring about AI when it became useful for them. Same way, internet was there 1983, but the common man did not care about it until people came out with applications like search, like browsing, like websites. Until that happened, nobody cared about internet, right? The common man, right? It was sitting in the lab. So the same way for quantum, now is the time when the hardware has reached some point where you can try and solve realistic problems. And that's where, the talent of India comes into play, because we have these people trained in Qiskit, trained in programming, trained in that way of thinking in terms of using quantum mechanics to solve problems. So this is the time now to enable these young people, give them that access to the quantum computers, to say that, okay, which are those problems? For example, it could be things in climate change, it could be new materials, it could be finance. I mean, beautiful example that came out of India is the DPI, right? Now, who doesn't use UPI in India, right? It has reached the corners of the country, all the small rural areas also people now use API. I mean, UPI, right? So we need to now start thinking, what is that problem which quantum can solve, which is going to make it that common thing that everybody is able to take it and use it. And as I said, the talent is sitting here, so we must make that talent think harder and come up with those solutions which is going to take quantum to the rest of the world. That's when the hype really gets, sustained, and it delivers something out of it.
And so, by when do you think we would reach quantum supremacy? Like a rough timeline, if you could give us.
Yeah, so IBM has said in 2 years, 2 years from now. Okay, December, the IBM Quantum VP, Jay Gambetta, announced that in 2 years' time, we are going to have quantum advantage. And as I said, IBM systems are the most advanced right now, 156 qubits. The software is, most used. Qiskit, the open source software that, the IBM platform runs, that is very widely understood across India and the world today. About 70% of all quantum system programmers use Qiskit today. Okay. And so now, so, and as I said, the hardware has reached a point where it is now able to do things which you cannot do using the best supercomputers. Your brute force simulation has been demonstrated that there are things you can do with the quantum computer now, which you cannot do with brute force simulation on the best supercomputers. So this is that time when you are going to start seeing. And as IBM said, 2 years. And remember, error correction has still not come in. Okay. When is error correction expected? At least on the IBM roadmap, it's 2029, right? So error correction hasn't hit in. But the important thing is you're saying now that even without error correction, I'm going to give you quantum advantage on real use cases, not some made up imagination, some use cases where it does not affect the common man, right? These are going to be real use cases where you're going to show that the quantum does much, much better, much faster, much cheaper. Any of these parameters you can take. And that's what you want to demonstrate, right? So 2 years is that time. And as I said, within that 2 years, we in India must, you know, challenge ourselves that it has to come out of here.
Yes, sir. And so, what application of quantum computing do you think would revolutionize the world in the next decade?
Yeah. So, I mean, right now I can only make guesses because
Mm.
any technology, for example, internet, who thought Zoom calls will be, I mean, the founders of that time, 1983, uh, they founded internet. They never assumed that there will be Zoom calls, there will be WhatsApp, there will be, all these things that we are doing. They were thinking more about the scientific applications. They were not thinking about how the common man is going to, use it and what kind of applications. But as I said, in quantum, we are seeing that one of the first areas that could benefit is new materials and life sciences, things like drug discovery, healthcare, these ones. Why? Because that molecular simulation that the quantum computer can do, classical cannot do, right? Which means that you now have a new tool at your disposal, which now tells you how molecules, come together, what kind of properties they might have, all of those things. And these things can be applied whether you're designing a new medicine or you're designing a new lightweight material for your car. Because remember, for your car, you need uh, the body to be strong, but at the same time lightweight, right? Same thing with rockets. Rockets need materials which go into space, withstand cold, heat, all those things. And at the same time, they are light so that the rocket fuel used is less, right? So all of these things is one area where you can very likely see a lot of benefits. And this might even have things like, whether it is, this climate change in terms of carbon emissions and all of those. There also you're looking for new kind of, how hydrocarbons can be better utilized, for example, or replacements for that plastic. So these are one area where you might see a lot of advantages coming out of the quantum computer, right? The other is things like, I mentioned complexity of data, right? Now, so for example, I keep giving this example, which is, you want to recognize a cat, right? To a child, human child, how many cats we show? Maybe one, two cats. Third cat comes along, baby says, Mama, cat, right? Now, for an AI system today, we need thousands of cats, to train them. Same data, same cat, the data representation and the data, how it stores and utilizes that data is different in our brain and the AI system. Okay. The AI system is making something simple as cat more complex. And that's why it needs thousands of examples to recognize that cat. So now comes quantum. Hopefully, quantum will have a better representation, which is closer to our human representation. So you don't need thousands of cats to train it. You need fewer cats, maybe not two like our human, but fewer cats, right? And that's all about that same cat representing that data mathematically so that you are able to, make sense of it in your analysis, right? And that's where quantum again is likely to score. And imagine that's a huge thing, because today AI is good, but it's not as good to be able to do processing. This extra cats it needs means it needs more power, it needs more time, it needs more GPUs, it needs everything more. And so it is making the AI unsustainable. You understand? Because to do that Billy problem, you are requiring so many GPUs, you are requiring so much power, you are requiring so much complexity to handle that data, and we need to simplify it. And quantum, in my belief, will simplify that representation for us, that representation space of Billy, car, everything, all that visual representation, right? Even the natural language processing. So the LLMs, for example, again, same, the data, you know, how you represent that data has always been a challenge so far in AI, right? So these are some areas where I think, quantum is going to aid and, make things much, much easier, better to do. And now, for example, our youngsters, a chemistry person who's already doing some chemistry, now start looking at what can I do with quantum? Okay, that will accelerate my things, that will help me solve tougher problems. Somebody who is doing AI already, come and start doing a little bit of quantum to see, okay, I'm doing classification of dogs, cats, ships, all that thing. How can I do it better using quantum, right? So you don't have to, break your brain to solve anything. You just take the problems you are already solving, try them on the quantum, and that way what I'm observing is your classical also improves. You get better insights to say that, oh, okay, this problem I've been solving, maybe this is how I need to look at it. And there are some new hybrid approaches which people are now coming up with, where they are using both classical and quantum to solve that problem which they were not able to solve, or which was taking too much time or too much effort, all those things, right? So I think that's the class of problems which we will start with. And once the youngsters get that access, get going, I have no doubt that we will start seeing lots and lots of beautiful, new ideas, new solutions, new products, new things. But we need to get started. That's the key. And the youngsters, as I told you, have, without universities offering courses, they have started. Nobody had to tell them anything.
Mhm.
So now we need to enable them further. You did things up to here yourself. Now take some help, get to this level. So I think if we do it in a nice way, there is no stopping us.
And so quantum cryptography is another important application of quantum computing. So when do you foresee quantum computers breaking RSA encryption?
Yeah. So okay, today, as you pointed out, RSA is in trouble. It can be broken. 1994, Shor's algorithm showed that there is this algorithm called Shor's, which does prime factorization very fast. Something which will take billions of years on a classical computer can be done within a few hours on a quantum computer. 1994, this was shown. Now, hardware hasn't been able to yet come up with a quantum computer which can run the Shor's algorithm in its full glory to break RSA at this point of time, right? But as I told you, quantum computers, Moore's law, similarly, quantum computers are also doubling in power every year exponentially, right? So in the next 10, 12 years, we are going to see quantum computers powerful enough so that they can actually go and break this RSA encryption, right? So what are countries doing? Countries are now coming up with what is called post-quantum cryptography, PQC, where they are saying, I'm now coming up, I'm going to junk this RSA, which is based on uh, prime factorization. The keys are generated using prime numbers. I'm not going to use that in future. And I'm going to replace this with a new technique. where it's lattice, some mathematics, right? Where I'm going to pick my keys from this lattice. And I know that, at least today, I know quantum computers cannot break this or make out these keys. So hence, what the world is now saying is within the next few years, we have to move out of RSA, which is prime factorization based keys, to this lattice based keys, which we today at least we know that quantum computers cannot break. And again, what does this mean for India? It means a huge opportunity, because within the next 10 years, countries, governments, banks, pharma companies, everyone is going to replace their RSA encoding with this new standards, the post quantum cryptography standards, right?
Mm.
Who's going to do it? Again, huge opportunity again for us as a country to train cyber security experts who can go and change this for the whole world. We go fix all the systems in the world and make them quantum secure within the next 10 years. And many countries have already said, I'm going to do it by 2027. Somebody says, US said 2035, but their organizations are saying we'll do it even before that, right? So every country is now on that path to secure their critical infrastructure, at least to begin with. Critical infrastructure is power, critical infrastructure is defense, critical infrastructure is healthcare, airlines. These at least they want to secure first round. Just go secure these so that no enemy country can come and say that power gone, India has power gone. So because everything is online now, you can hack into these kind of systems if you have that capability, right? So those are the first ones that are happening, and everything is going to happen in the next 10 years. Okay. And that doesn't mean you wait for 10 years. It means you start now and complete it within 10 years.
Yeah. And so, since we're running short on time, I'll ask you this last question, which I'm sure everybody will appreciate. How can you advise quantum enthusiasts who want to enter this field, students and professionals? What would you advise them? How do they start? What skills do they uh, start with? Resources, all of that.
Yeah, sure. So many UG students come and ask me, what is there anything in it for me? Okay. And the answer is yes. UGs are being hired by IBM. My team is hiring UGs. Okay. Then there are all these startups which are getting funded by the government and VCs and everybody. They are also getting hired by, and again, UGs, PGs, everybody. It's not just limited to PhDs. Okay. People are getting hired at all levels. But who is getting hired? The person who is getting hired is the person who has actually gone and gotten their hands dirty with code. They have an active GitHub with lot of commits. They are the people who are getting hired. People who have coded in Qiskit and built things. And as Qiskit is open source. So have you gone and contributed anything to that? And what I'm also seeing is that these people who have these commits and everything, even the classical companies, whether it is AI, whether it is somebody else, they also value them. Okay. So you don't have to only look at quantum jobs if you are good at quantum, hands on, right? You can get classical jobs also. Okay. The other thing is the National Quantum Mission. The government is putting so much money, and the government wants youngsters to become junior research fellows, senior research fellows, come and join the MTech programs. The government has started AICT plus DST have just started this minor program in quantum technologies starting this year, where students of any branch can come and take this quantum course, 6 courses, and then you get a minor degree in quantum technologies. Okay. You can be a civil engineer, you can be a mechanical, you can be a computer science, whatever. You can get that, right? So this is a beautiful opportunity, but don't just look at theoretical understanding. We have to go and take that understanding and build something in the lab, build something on the computer, but be hands on. The hands on person is valued over the person who comes and says, I got 10 point CGPA, but I don't have anything I have built. That guy, no. That girl, no. It has to be somebody, does not matter your CG is low, but if you have built things, if you have contributed to open source, if you have gone to the lab and done some experiments, shown something, built new material, something, wherever you have gotten your hands dirty, and even if you have failed, does not matter. You tried something, it did not succeed, it's much better than not trying at all. Okay, so every student must look for these opportunities to build something. Go LinkedIn, everything, email, you can find everything these days. Just go and catch people, say that you will work for money or free or whatever chance you get. And not only in India, worldwide. Okay, and as I told you, talent is scarce everywhere in quantum. And if you are a quantum talent, you have no limits. Okay, people will take you from anywhere in the world today. So the biggest suggestion is be hands on. All the tools, everything is available online. Learning resources, Qiskit videos, Qiskit, documentation, tutorials, everything. Computer is also on the cloud. You can use it. Simulators are there. So many assets are there. You are a privileged generation. All you need to do is go figure out where it is and start using it.
Okay, so this is an insightful conversation for me, and I'm sure for the viewers as well. Anything you want to cover about your book, sir? Quantum Nation.
Nah, Kiran, I'm happy you asked about the book also. So, yeah, I mean, the book is really just a starter. Okay, this is the first edition for all of India, saying that you read this and you get to know what is happening here. Okay, the next versions are going to be written by you. For example, Kiran, you are going to write the next edition of this, saying that this is what I did and here is what I've built, this is what I've done. And so this is just the starter. Just start here and understand what is the landscape. It's not a technical book at all. It's more about giving you that big picture about where is quantum in India today, how good our talent is, what are the paths in front of us, and you pick your path and write the next book about you succeeding and inspire all of us. That's what it is. Yeah. So thanks, Kiran. Yes. So Kiran, thank you so much. I really enjoyed our discussion, and I'm really happy about the work you keep doing, inspiring young people, because I think you're seen as a role model. Many kids see you as somebody who's showing them the path, and we need you. Okay. So thanks a lot, and congrats on all the shows you've been doing. I keep watching them. So it's been a good journey for you also. Thank you so much. Yeah.
Thank you so much, sir. It was lovely talking to you. It was very insightful for me, and I'm sure for the viewers as well. And I'll link your book down below in the description as well for people to read. And I had a lot of more questions to ask you. I'm sure we can do another podcast later after a few months.
Sure, sure. Anytime. Yes.
Thank you, sir.
I
Thank
was
you.
really happy when you reached out to me. I was thrilled because, yeah, as I said, I've been following your work, and I was happy when you invited me. So thanks a lot. Yes.
Thank you so much, sir. Thank you.